Okay, so these problems are very similar to the ones that were on the homework yesterday. We're pretty much just doing additional examples to make sure that we're all on the same page. We're trying to look at a few that are a little bit harder than the ones that were on your homework that was due today. So when we look at this first picture, we should notice that we've got plenty of information to check for similarity. We have lots and lots and lots of information. So what we should do is we should try to set up the proportion and check to see if the side lengths are proportional. We have all three, but in reality, we don't need to do all three because we've also got enough information to declare one set of angles, because those two angles that I just marked, those are vertical angles. So in theory, we could check side angle side similarity, which would require us to pair 5 with 12.5. And 8 with 20. Now, we could go ahead and check side similarity as well by adding that third fraction and doing 6 over 15, but we don't have to. Okay, we can just check side angle side and we'd be good. Okay, so you could do the problem either way. It doesn't matter, but if you recognize that you've got these vertical angles, then that allows you to use side angle side and it's a little bit less work. So we would check those fractions to see if they are in fact equal. We would just take our calculator and divide 5 by 12.5, which is 0.4. And we would divide 8 by 20, which is 0.4. So that works. Those are the same. We've got and remember that decimal is your scale factor. That's telling you that the scale factor is 4/10 or 2 to 5. Okay, so your answer here would be yes. Then we have to write our similarity statement. We'd start by naming one of the triangles. It doesn't matter which one. It doesn't matter what order you name it in. So let's say we name the little triangle PQR. If we name that PQR, we should realize that P and S are related to each other. So S would have to come first in the name of the second triangle. Q would relate to T, so T would go second, and R would go last because we have shown side angle side similarity. Okay, we could even state the scale factor. Again, the scale factor would be 2 to 5, but that wasn't required in the directions, so it's not necessary here. The second problem on this page is a little bit harder because those triangles are nested. So you have to be very careful when you're doing this next problem. What we're looking at there, we got two different triangles in that picture. We have the little triangle, AEF, which has 8 and 10 for side lengths. And we've got the bigger triangle, ACB. And to find its side lengths, we actually have to add the numbers in the picture. 8 plus 4 gives us 12 for AC. 10 plus 5 gives us 15 for AB. Now that's only two sets of side lengths, so we also need a reason why this angle in between those side lengths is congruent. Well, in the original picture, it's reflexive. So that angle would be marked congruent because it's the same angle in the original picture. So those two angles are reflexive. That gives us our angle pair. Sort of like up here, our angle pair was PRQ was congruent to TRS because they were vertical. Here we have angle CAB is congruent to angle EAF because it's reflexive. Okay, your reasoning should contain an actual statement of congruence plus why the angles are congruent if you're going to do side angle side. Okay, so then we need to set up the proportion. It would be, again, smaller side to smaller side, so 8 to 12. Is that equal to bigger side to bigger side, 10 to 15? Now, in this case, neither one of these fractions contains decimals, so we really probably shouldn't need to use the calculator. We should just be able to reduce those fractions. 8 divided by 12, they're both divisible by 4. That reduces to 2/3. 10 divided by 15, they're both divisible by 5. That also reduces to 2/3. So in both cases, the fractions reduce to 2/3, which means that they are in fact proportional, which means that we can state that, yes, triangle ABC is similar to triangle, and it would be AFE by side angle side similarity. Okay, so these are just some harder examples. They're a little bit harder to see. This first one, you had a couple different options on how to approach the problem. You could have done side, 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 or side, angle, side. It doesn't matter. On the second one, it does have to be side, angle, side, but we have to recognize that there are, in fact, two triangles in that picture, and that we get the side lengths for the larger triangle by adding the 8 and the 4 together and adding the 10 and the 5 together. All right, so that takes us to, and I'll be happy to put this back up at the end of the period if you need more time. Once we know that we've got a pair of similar triangles, we can actually use the fact that we have similar triangles to find missing side lengths, to find the values of variables. So let's have a look here at this next page, where we're asked to find the length of BE and the length of AD. So here we've got some nested triangles, and we have to recognize that we have plenty of information to declare that these triangles are similar to each other. For instance, both triangles, the smaller triangle ABE and the larger triangle ACD, both have angle A, which is reflexive. So that's one set of angles with that marking right there. The parallel markings on BE and CD allow us to state that we've got a second set of congruent angles there in BEA and angle D, because those angles are corresponding. So that gives us our two sets of angles, which means that triangle ABE is similar to triangle ACD because we have shown angle-angle similarity. We have two sets of similar angles. So what that allows us to do is it allows us to solve for y, and to solve for this missing side length. Let's add a variable and call it x. And those would be the information that we need to answer the question, because we're asked to find the length of BE and the length of AD. So to do that, we're going to have to find the length of AE, which is marked with y, and we need to find the length of BE, which I just added an x for that. So one thing I do suggest is that when your triangles are nested, I highly suggest that you redraw your picture, because it can get a little bit confusing if you don't pay close attention to the various pieces as you go. So if we redraw this picture, the smaller triangle is ABE. We have side lengths on that of 3, y, and x. And the bigger triangle ACD, well, it has side lengths of 3.5, 5, and here's the tricky one, y plus 3 for AD. So that allows us to set up our proportions. Okay, and I know that I've been circling, but I'm going to use color this time only because they're separated now, so I don't want to circle stuff quite as thoroughly. So if we look, we have each set of sides corresponding to each other. 3 corresponds to 5, x corresponds to 3.5, and y corresponds to y plus 3. So to find the value of x, we are going to set up the proportion AB is to AC as BE is to CD. We're not going to involve the sides that include the letter y when we're solving for x. We're going to ignore those 2 sides and set up a proportion with the other 2 sets of sides. So when we plug in the side lengths, that would be 3 is to 5 as x is to 3.5. Once we have that proportion, all we need to do to find x is cross multiply and solve. So we would cross multiply 5 times x, 3 times 3.5. That would give us 5x equals, excuse my morning brain while I multiply 3.5 by 3 on my calculator, 10.5. Then divide by 5. And we get x is 2.1. We do something very similar to find the value of y. We set up the proportion AB is to AC as AE is to AD. Notice that I left out, when I set up my proportion, I did not use the sides that involved x. I used the sides that involved y so that I can find y. Plug in those side lengths. Again, that's 3 is to 5 as AE is y and AD is y plus 3. Again, we cross multiply in order to solve our proportion. That would be 5y equals 3 times the quantity y plus 3. Distribute would give us 5y equals 3y plus 9. Subtract 3y from each side. So we distributed. And now we're going to subtract 3y. I'm also going to move it up here. That gives us 2y equals 9. And then we divide by 2, which gives us y is 9/2 or 4.5. Now the only reason I'm writing that as a decimal is because I already have decimals in the problem. So it makes sense to give the answers as decimals when we're talking about the side lengths, because in the problem we had a 3.5 in the original problem. So it would be fine for you to give me decimal answers if the problem itself contains decimals. Now we found x and y, but that is not what the problem asks us to find. The problem asks us to find BE and AD. Well, BE is easy because BE is equal to that x that we added to the problem. So BE would be 2.1 units. For AD, we would say, okay, well, that's y plus 3. So that would be 4.5 plus 3, or 7.5 units. And you could give me either one of those as a fraction as well. That would be fine. I would accept either answer. Okay, so before we go to the next slide, does anybody have any questions on the ones that we've done so far? Just unmute and ask if you got a question. All right then. Another common similar triangle problem that we will see from time to time is the old shadow problem. So for instance, at 6 p.m., the Ferris wheel on Navy Pier casts a 200-meter shadow. At the same time, Mr. Wills, who's 2 meters tall, Cast a 5-meter shadow. How tall is the Ferris wheel? First of all, I want everyone to appreciate my great artistic talent here. I think that looks exactly like me. But anyway, we need to label our picture, but here's the basic idea. Whenever the sun is shining, it is hitting every object that's located in the same place at the same angle. So we've got an angle right here called the angle of, I believe it's called the angle of incidence of the sun. Not that that's important, but basically in every shadow problem, that top angle will always be congruent. And then we've always got Boxy down here on the ground between the person and their shadow, which is on the ground. So that gives us two angles. That gives us angle-angle congruence. Okay? So let's label our pictures here. Navy Pier, let's see. The Ferris wheel casts a 200-meter shadow, which would be on the ground. At the same time, Mr. Wills, who is 2 meters tall, casts a 5-meter shadow. And then it asks us how tall is that Ferris wheel. So we're finding that height, X. So because these are similar triangles, we are able to set up the proportion X is to 2 as 200 is to 5. And then from there, it's a relatively simple problem. The hardest part is getting the picture drawn and labeled. Then we set up our proportion and we cross multiply. So that gives us 5 times X and 2 times 200, which would be 400. Simple one-step equation to solve. We divide by 5 and we get X is equal to 80 meters. So we would say the Ferris wheel is 80 meters tall. Making sure to answer the question and include units. Remember that word problems require word answers, folks. I would expect you to give me a one quick statement that answers the question. All right, let's do one more example here and then we'll call it a day. I think that's fair. Everybody good? Okay, last problem for the day. Identify the similar triangles, then find the value of X, VT, and RT. So again, there's a couple things about this problem. One, we've got nested triangles again, which means that we definitely have similar triangles, okay, but they're nested. So we've got this angle here, and we don't have a letter, so we need to add a letter. Let's call that point there X, because it doesn't have a letter. Okay? The little triangle is XRT, and the bigger triangle is XQV. So when it says identify the similar triangles, it wants us to write a similarity statement. So we would just quickly say that XRT is similar to XQV. That takes care of the identification of the similar triangles. It just basically means write a similarity statement. Now, from there, we need to label our pictures with what we know. Well, here's what we know for sure. Because QX and XV are the same length, they're both 36. That means that all four of these angles would have to be the same because these are similar triangles, which means they have the same angle measures between the two of them. And since the bigger triangle is isosceles, the smaller triangle has to be isosceles as well, which means that xt, which is 24, and rx, or I guess that's got to be, rx are both 24. Sorry, I stumbled on my words a bit there. Okay. Now, that means that we should be able to realize that we've got 36 here and 24 here, and the difference between those two is x. So we should be able to set up a segment addition postulate. See, sometimes this doesn't even involve similar triangles. It involves stuff from earlier in the year to write out the equation qx, qx, I started to write qr, qx equals xr plus rq. Since r is between x and q, we can set up segment addition postulate to find the length of x. Well, that's relatively simple. Qx is 36 units, xr is 24 units, and rq is x. So a quick subtraction. To subtract 24 from each side, and we get x equals 12, which means that if QR is 12, VT is also 12 units, which is one of the things we were asked to find in this problem. Now, the other thing we're asked to find is actually designed to scare you. You'll notice that QV is listed as being 36 times the square root of 2 units. Now, you've all taken Algebra 1, so radicals should not scare you, but they probably still do a little bit because you're not 100% comfortable with them. 36 times the square root of 2 is just a number. It is just a real number. It's not anything that should terrify us. Basically, if we need to know the length of RT, we could just insert some variable there. Let's say we write in a y. And then since these are similar triangles, we can just set up a proportion. 24 is to 36. As y is to 36 root 2. And then we cross multiply. Now, when we cross multiply with a root, you just ignore the root. You treat the root like it's a variable. Treat it like it's an a. So if you did like 24 times 36a, you're really only doing 24 times 36. So we do 24 times 36, which is 864 times the square root of 2. And otherwise, we just ignore that root. It doesn't change anything, okay? On the other side, we'd have 36y. So we have 36y equals 864 root 2. And then we solve that by dividing each side by 36. And we can still just ignore that root 2. It can just sit there and just continue to be like a variable. So y equals 24 root 2. And if y is equal to 24 root 2, then RT is equal to 24 root 2 units. I don't need a decimal approximation of that. Your calculator is capable of giving you a decimal approximation, but I don't want an approximation. I want the exact answer. Okay? Okay, so that does it for today's lesson.